Swayam Prabha. Digital India. Educated India.
I understand you have a quiz today, 3 o'clock? 5102? Okay, and you are here to prepare essentially for that quiz, is it? Yes, sir, good. So while you guys are preparing for the quiz, let me drop a bombshell to you. With some exam details, they are now available on my website. Date is on the 22nd of February, 2013. The exam is going to be conducted in 2 batches, batch 1 and batch 2. I'm going to be announcing the roll numbers shortly. The first batch is going to be having the exam from 10 a.m. till 1 p.m. The second batch from 1:30 p.m. till 4:30 p.m. Okay. So these are the details. So there will be 5 questions that I'll be asking you to answer in 3 hours. So so far you have been doing 3 questions in 3 hours. In the exam, there will be 5 questions in 3 hours. Absolutely no sharing of information before or during the exam. Because remember, the exam is going to be held in 2 batches. And most importantly, equipment. Okay? So no sharing of drafters, set squares, pencils, erasers. I request you to bring only your mini drafter, your drawing instruments, set squares, stencils, pencils and eraser, a piece of cloth. They can be brought in a file folder or a simple polythene bag like this. Okay, keep everything except for your mini drafter inside and bring this along with you. It's very important for you guys not to bring your bags and cell phones. You will not be permitted to keep your bags and cell phones either outside or inside the hall. Okay? For batch 1, I want everybody to be inside the drawing hall by 10 o'clock sharp. Okay? 10:1, things become difficult. 10:2, things become more difficult. 10:5, 10:10, things become impossible. Don't do that. 10 o'clock sharp, I want everybody inside. For batch 2, likewise, I want everybody inside the drawing hall by 1:30 p.m. Capital S, capital H, capital A, capital R, capital P. Sharp. Okay? Okay. So I might as well give you the questions so that you can go home, prepare the sketches and come to the exam. Okay, so here's question 1. No, I wasn't serious. Things will become a little difficult in between 1 and 1:30. Okay, so we have a plan. And it's there on my webpage, but I just want to explain to you. So students or pupils from batch 1 will be working in drawing hall 1 and 2. Okay, around 1 o'clock they'll come out. They'll follow the blue arrows. Okay, so there's this corridor that you already know. The end on the left leads to the faculty building. The end on the right leads to the IME building. Okay, so you guys in batch 1 will step out and turn to your right and stay here for half an hour. You will be quarantined, cordoned. Stay there for half an hour till pupils from batch 2 occupy their places in the drawing hall. By 1:30, you will be released, batch 1 will be released, batch 2 will be ready for the exam. Okay? These are the barricades. And we'll make sure that there's no mass transfer, momentum transfer, energy transfer across these barricades. Physics 102. Okay? No transfer of information. So last time we did missing lines. This time we are going to do missing views. So those who are coming late, make sure you don't do that on the 22nd of Feb. Just by 30 seconds or 1 minute, the doors are going to be closed of the main drawing hall, and we can't do much. Okay? So make sure you're on time, or rather before time in this case. So little basics. The region in the red, front view, the region in the green, top view, the region in sky blue, right hand side view. Okay? Hinge lines. If you have a point in one of the views, what would its image look like in the top view and the profile view? Necessarily a line, could be a point, and could be a line. So if the image of this point in one of the views is a line, okay, then if you project this thing in the third view, you'll get another line. Okay? Okay, so these lines are going to be perpendicular to the respective hinge lines. Okay? This is true for all image planes or all views. For example, if you have a point in the top view, and if its image is a vertical line in the front view, okay, if you take the image in the profile view, it's going to be a vertical line. Okay? Likewise, if you have a point in the profile view, in this case the right hand side view, and if its image in the frontal view is a horizontal line, you take the respective projections and you'll see that the image of that point in the top view is also going to be a horizontal line. So far so good? If you have a slant line in the front view, and if its image in the top view is a horizontal line, then what do you expect? A vertical line? Wunderbar. If the image of that line in red is another slant line in the top view, what do you expect? Slant line. So these are certain basics that you have to keep in mind. If there's a line which is vertical in the top view, and if its image is also vertical in the front view, what do you expect? The image of these two lines. Huh? What do you expect? Break this down. Consider a point on the line. Okay? The image of this point is this line. Figure out the corresponding image over there. Consider this point. Image of this point again would be a line. Figure out the corresponding image over there. And do the other way around as well. This point, this image, this point, this image. What do you get? You would get a rectangle. Okay? So this is something which is important. Okay? Yeah? So both are possibilities. So some of you are saying that this diagonal is also a possibility and this diagonal is also a possibility. Right? Do you agree? Good. So what does that mean? The solution is not unique. The solution is not unique, which makes things even more challenging. when you are thinking about missing views. Okay, I will come to that. But for now, let's stick with the rectangle thing. So the impression, given information of a point or line in two views, their projection in the third view should be possible. May be unique, may not be unique, depending on the situation. Okay, but it should be possible. All right, I will try to use this information to try to construct the missing view and alongside the three-dimensional object. Just in case, let's say if I extend this line by this little bit, okay, the image of this line is also this green line. If I take the respective projections, I'll get another plane in the profile view. Okay, so uniqueness is something that we'll have to address while constructing the missing view as well as the solid. Let's take this first example. Two views are given, the front view and the top view. And when I say two views are given, I mean that nothing is missing in the two views. The entire information is given. What is not given is the third view. Okay? And we have to draw that. So while I am going to be drawing the third view, I'll also be drawing the three-dimensional solid that the three views would represent. Okay, so here we go. Look at this figure carefully. You can think about this figure as being divided into a bunch of lines and points. Likewise, you can think about dividing this figure into a bunch of lines as well. Let's focus on this line and this line. Okay, so these two lines would represent what? Okay, assuming that we're not thinking about the diagonal lines as of now, that would represent the plane. Okay, and that would represent the plane on the back side of the object. So this is what the plane is. Right? Okay? So if you're with me, say yes. If you're not with me, raise your hand and feel free to ask a question. Okay, how about this line and this line? You'll also get a plane. Okay, now what I've done is I have drawn the extended plane. So I've assumed that this line extends up till this point over here. Okay, just to get the solid in perspective. Okay, I've drawn this plane so that the plane extends till this edge. Okay, how about this vertical line here and this vertical line here? I'll get this plane. Okay? Okay? And then this edge is something that I see in the top view from here to here. This edge is something that I also see in the top view from here to here. This bottom edge is the same thing. I see this in the top view, and also I see a part of this in the front view. Okay. This vertical edge I see in the front view. Right? Top view, right vertical edge. Front view, the vertical edge on the right. Top view. This is again the front view. Okay? Okay, at this point you have some information as to how the solid might look like. Okay? Use your judgment and try to finish the solid. This is how the solid might look like. Okay? Once you know how the solid looks like, the front view, you get the front view when you look at the object along this direction, you get the top view when you look at the object from this direction, and the right hand side view is from this direction. Okay? You are ready if you're convinced that this object, if you're convinced that the front view and the top view shown, okay, correspond to the object that you have drawn. Okay? You're ready to draw the right hand side view. Use projections. You would see this face. You would see this face. You would see this face. And then you would see this face. Okay? Things can get tricky. Things can get tricky, so you'll have to be a little careful. Okay? Another way to think about this. Start with a three-dimensional block. Start with a three-dimensional block. Assume that's solid. And depending on what your views depict, start cutting different parts from that block. Okay? That's the other way. So assume that you have a clay box or a box made of wax. Start cutting different blocks, different parts from that till you get your top view right, your front view right. Okay? Once you're convinced, then you are ready to draw the profile view or the third missing view. Okay? So it's experience, essentially. There's no method that is the right method. Okay? So it's experience that's going to help you draw these objects. Example 2. The front view given, the top view given. Okay? Use the fact that the image of two vertical lines in the two views will be a plane in the third view. Use that fact. Corresponding to this line and this line, you'll get a plane at the back. Right? When you say, so when you agree, say yes. When you agree, say yes. Okay. Corresponding to this line, how many lines do you see here? 2. Is it? Yeah? 1, 2. How many planes do you expect? How many planes do you expect? So the image of this line is this guy over here. The image of this line is also this guy over here. And by the way, this is also discretized into two vertical lines. Right? So how many planes do you expect? For now, let's say there are going to be 4 planes. This is the first plane. Okay, that would correspond to this line here and this line here. Second plane corresponding to this line and this line. The third one corresponding to this and this. And the fourth one corresponding to this line and this line. Okay, what would this plane correspond to? This and this. How many planes do I expect here and here? or these planes? Yes? Okay. Do I see this line in any of the views? Top view? Do I see this line? Do I see this line? Top, front? Rather both. Okay? Do I see this line? Do I see this? Do I see this? Finish your object and now try to sketch or try to outline the object in 3 dimensions. And your object will probably look like this. Yes? Simple, is it? Simple? Okay. Good. So once you have this object, now you're ready to draw the missing view. Which would look something like this. Yes? Good. So far so good? Let's think about loops. Loops. A loop is, what is a loop? You know what that is? Let's think about loops. How many loops are there in the front view? How many loops are there in the front view? Well, actually, mathematically there are 3. But for now, we'll assume that these loops are not intersecting with each other, and one loop is not enclosed in the other loop. Okay? So this is the loop that you see in the top view, this guy here. This is the loop that you see again in the top view. This is the loop, the L loop that you see in the front view, and then you see a rectangular loop again in the front view. Okay? Okay? Now the problem is just to place these loops appropriately in 3D. How do you do that? Let's see. So this is where the green loop is. Okay? This is where the image of the green loop is. Okay? So the green loop is here in the top view. The image of this is at the top in the front view. So this loop stays here. The red loop, okay, this loop, the image of this is over here in the front view. Right? So this loop, what happened to it? It'll go down. Okay? The image of the sky blue loop in the front loop is at the bottom in the top view. Okay? Yeah?
Explain why did that red loop go down?
This is your red loop. Okay? What's the image of that in the front view? This line here. Okay? There's a difference in height between the green loop and the red loop. Okay? So if the green loop is staying at the top, the red loop is going to be pushed down. Right? This is your sky blue loop. Okay? The image of that is here in the top view. So this sky loop will stay there. How about this loop? Will it stay there? Will it get pushed? Along which direction? So what you have done instead, so these loops, they represent different faces of a three-dimensional object. So what you have done is you have determined their placement, their relative placement in 3 dimensions. Okay? Once you have done that, all you need to do is draw the missing lines. Right? Simple? Again, once you know the object, you know the missing view. Okay? How about this? How many loops do you see in the front view? 2. One of them is the one in the light brown. So these are 2 loops that you see in the front view. Correspondingly, in 3 dimensions, they are where they are placed. In the top view, how many loops do you see? 1, 2, 3, 4. Fine. You need to play with them. You need to push them back and forth, down and up. Okay? This is where your red loop is. It stays at the top. Your sky blue loop, this one, gets pushed down by this height. Okay? The brown loop gets pushed further down. Okay? The purple loop stays where it is. The light brown loop gets pushed along this direction. Okay, once you have placed these loops appropriately, fill out the rest of the lines. The green loop. Okay. The green loop comes down. Okay? Now fill the rest of the lines. Complete the rest of the lines. Once you know the object, you know it's 3-dimensional, you know it's third view. Given 2 views, this is a little tricky and challenging. Would the loop method work here? Anyhow, let's do conventional stuff. This plane corresponds to which 2 lines? This line here and this line here. Okay? And this plane corresponds to this line, this entire line, and this line at the back. Okay? Likewise, the plane here on the front corresponds to these 2 lines. Right? Okay? With me? With me? Good. So this is your plane of the front view. This is your plane of the top view, of course, and this is your plane of the profile view. Okay? In the front view, you would possibly see a line here. Okay? Essentially this space here. Okay? And then you would see something like this. Right? This is the tricky part. This is something that you will probably need to guess. Okay? You will probably need to guess. If you look at the solid from here, you'll see this line, you'll see this line, you'll see this line, and you'll see this line. But if you look at the solid from the top, you will see this triangular wedge taken out from the block. Okay? Corresponding to which you have this triangular feature here. Okay? Now how about these 2 triangles? It's a plane. It's a slanted plane. Are you sure? No, sir? Well, if it is a set of planes, if there are like two planes, then there has to be a line of discontinuity between those planes.
That line is the diagonal of square.
So what you're saying is these two triangles will constitute two planes. Huh? Try it out. Try it out. But let me go with your option first. A single plane, a slanted plane. Okay? So one of the vertices of that plane will be somewhere here. The second vertex will be here, and the third vertex will be here. Correspondingly, the second vertex will be here, the third vertex will be here. Okay? Now imagine that you're working with this. Imagine that you have drawn the solid. Now try to verify if you get the projections in the front view and the top view right. If you do, the solid is okay.
The line I was talking about was this line.
Was which line?
The diagonal.
This line here. Okay. So remember this golden rule, that if you're getting two planes, or if you're getting a single plane with 4 points lying on the plane, make sure that all 4 points are coplanar. Otherwise, you're not doing things right. Okay? Once you get the sense of how the object is going to look like in 3 dimensions, work out the outlines. Once you know what the object looks like, work out the third missing view. Let me tell you, and let me warn you rather, that this is not at all trivial for certain cases. For certain cases, straightforward, but for many other cases, it's not trivial. So you have to give your CPU a hard time. Yeah?
So I think there should be another solution to this. Because the diagonal you drew over there.
Let me.
Yes, sir, this one. Instead of drawing this diagonal, if you take the fourth corner of the square and you join the 2 points, like the one, yes, these 2 points, then there would be 2 planes, and there would be a line of discontinuity, and it will.
But would the corresponding line appear over here? Yeah, absolutely. You're most welcome.
Instead of having this line over here,
Yeah?
I can join these 2 points over here,
Yeah?
and then I have 2 planes.
Yeah?
One would be this one,
Uh-huh.
and another would be this one.
Uh-huh.
So this line won't be visible in these 2 images because it would be hidden behind these 2 lines.
How about the hidden lines then?
So,
How about the hidden lines?
so the hidden lines would be behind these 2 lines.
Are you sure? Try it out. Try it out. Try it out. So there could be multiple solutions. So try it out. And do verify if the loop method would work in this case. Another example. So this time I won't speak, I'll let the screen speak. Okay? So just follow and stop me wherever you have doubts. Do you agree? Are you with me? Good. Okay, I'll talk about these red lines later. But for now, let me finish up the solid. Would those red lines be there? Dot on the money. Okay? Okay? Again, coming up with the third view is not so difficult. Okay? How about the loop method? You see the first loop here? Trapezium. Second loop, rectangle. Third loop at the top. Fourth loop again at the top. And then you have this rectangular loop at the top. Okay? And you have this triangular loop on the front, or in the front. Okay? The purple loop, okay, has to go where? Okay. The red loop has to go where? Yeah? Okay. The green loop, stay there? Okay. The brown loop, would it stay like that or would it change in shape? Like so? Okay. The sky blue loop stays there. The black loop here. Make sure you have the solid, and once you have the solid, you have the profile view. Two problems before you go from here. On the left are shown the front view and the top view of solid 1. On the right are shown the front view and the top view of solid 2. They are identical to each other. Okay? And at this time, it does not matter if you're using a first angle scheme or the third angle scheme, since they are identical to each other. Okay? In both cases, try to find how the respective solids will look like, number one, and once you do that, try to find the missing profile view. Okay?